top of your assignments, either here in Canvas with your to-do list. It'll always show you things that you still haven't done and that you need to do. It will probably show you upcoming things. So the planet Earth was due last night for you guys, and today we're doing a metric measurement lab, which is due tomorrow. And you can see from our agenda that we are going to wrap this up, as I mentioned, with one more topic about the themes of biology, and then we're going to do a review. I also want to comment about the textbook. So right up here, it says how to purchase and install our textbook. Raise your hand if you have purchased a textbook and you have your code. I think you did it on Red Day even. So I suspect that half or 90% of you already have purchased a textbook. If you have not purchased a textbook, that's also your homework. You will start needing your textbook on September 16th. So you do have a couple of weeks, or at least 8 days, to get your textbook purchased. Don't worry about getting it integrated into Canvas. We're going to do that together. And I'll record a video on it, and we'll spend some time with it. So perhaps I'll do that a little bit on the next class. We'll see. I don't want to take time today. I want to encourage all of you who have not purchased a textbook to do so by going to the bookstore and saying, hey, I need to get my book for biology class. And they know that this is biology section 521, so they'll get you the correct book. And then it takes 2 to 3 days once you purchase it to get the email code to you, so you'll need that code. So please take care of that. It's an electronic version of the textbook. It integrates into Canvas, and it has all this study area that we're going to be using. So please do that. I'll catch you if you are dragging your feet on not getting your textbook, because we are having assignments starting the 3rd week of September that are only available if you have your textbook. So make sure that you remind your parents that, hey, I've got to get my textbook, so they can even buy it for you at the bookstore. Yes?
What's the planet Earth assignment?
We watched a video in class about the characteristics of life. Remember that? Okay. Interesting video, isn't it? It's fun to see animals in their normal behavior instead of in a zoo. And some of my classes really got into some of the predator-prey chases, and they were rooting for the underdog. A lot of times they're rooting for the prey. So you have to realize that, that is what happens in the world. Competition. There's not enough space. There's not enough food for all animals, and not all animals make it. It's part of the food web. And that's really part of our next unit on ecology. And we're jumping from chapter 1 to chapter 23. And we'll spend a few weeks there, and then we'll come back to chapter 2. So let's talk a little bit about some skills. I have mentioned that we are going to have data tables. How you make a data table. Expect that you are going to be asked to take some data and put it into a table, and to build formulas, and to build a chart, and to format your tables and chart correctly. So I'm going to go over a few. This looks good, and what do you think about this? So this is the density lab. You see the data table? I don't know if I can zoom in on it. Good, just a little bit. So how's it look? It doesn't have any units of measurement inside the cells right here. Is that correct? It just says 8.4. Shouldn't it say 8.4 grams? No, you don't put the unit of measurement in the cell itself, only in the column heading. So I have given that to you, but when you build your own, then make sure that you don't put any units inside the cell. It's always at the column heading. The directions for this lab were to format this column to 1 decimal place, this to 2 decimal places, 2 decimal places, 2 decimal places. And how many decimal places were supposed to be in the density column? Only 1. It was in the directions, but the logic behind it is that density is grams divided by milliliters. Grams had 1 decimal place, milliliters had 2 decimal places, so your answer can only be in the least accurate number. So you couldn't go to 2 decimal places. That would show that we had too much precision because we can only go to the 10th of a gram. So yes, that data table looks great. It has a title. Don't call your table Table 1 unless you have a legend that says Table 1 equals density of liquids and solids. It's so easy to name your data table and chart. Just name it the name for the lab itself, and that is what it was. What do you think about the chart? Does it look good? Anything missing? We have it. We have a title. We have our units right here. Or I should say our series: water, rubber stopper, square, sphere. The x-axis label, is that good? Objects? Yep, that's what they are. If you ever wonder what to do for your x-axis, did you notice that the first column in your table is your x-axis? And the title for your x-axis is right up there at the top of that left column. But also, it should just make sense. So once again, thanks for not having headsets in. I know it's kind of a habit after lunch and stuff, so no headset? Thanks. Busy listening to music. And right here, density, grams per milliliter. These numbers right here, you have to say what they are. If all you said was density, it's only half right. Density is mass divided by volume, but sometimes the units can be different. It could have been cubic centimeters. So just be accurate with, hey, what do these numbers really mean? Remember the plant table? Some people just put the word growth. Some people just put the word millimeter. But you really need both of them together. Because otherwise, is it the growth of the seed? Is it the growth of the fruit? The flower growth? So it was really height of the plant in millimeters. So just try to be as accurate as possible so that there's no question as to what this is. This passes the 3-second rule that I have told you about. You need to be able to look at a chart and in 3 seconds get all that you need to out of that chart. Isn't this simple? Density of liquids. All right, water, that's a liquid. Rubber stopper, square. Okay, objects. Wow, that one is really big. 8. That's the highest density number. That's the lowest density number. That's kind of like what you need to get out of the chart. I'm going to show you another chart that looks like it's complicated, and you might think it's really good because it's complicated, but if you can't get the information out of it in 3 seconds, something's wrong. Split it into 2 or more charts and make it simple so that people have really short attention spans. I mean, look at you guys. You looked at this for 3 seconds, then you looked away. So that's the power of a chart. It's meant to show the graphical results in an instant, 3 seconds or so. Every other number up here was just to get at that column. So only chart the important end result. Now here's another chart. I kind of meant to show this one last because this was a good job. And I'm trying to get out of my chart here. This is just a picture of someone's homework. And all right, good. That was a good spot. Here we are over at the plant growth. The data table looks great. Units of measurement here. They could have shrunk this, right? Because that number is small compared to the overall width. So you could clean it up, take up less space. It's a little neater. That's somewhat of a style issue. How about the chart? The chart look good? All right, 3 seconds are done. What's the information in this chart? If I just gave you the chart, could you now tell me that the outcome of this? No, it's pretty. Got a lot of colors. It sure looks important. Somebody smart should be able to get it, but I can't get it. Too much information, and so much is missing. There's no title. Pot A, pot B, pot C. Man, are they growing marijuana? What is this? It doesn't make sense, right? So what is a pot? Are we cooking? Is this on the stovetop? The legend is not your title. The legend is usually up there near where the title is. You should almost always grab it and move it somewhere else. I like to move it inside the table, underneath the table, but it rarely belongs right there. When you turn the title on, the two are almost always overlapping. So drag it out of the way. All right, looking at this chart, 1, 3, 5, 8, 10. All right, what the heck is that? Are we talking days? I don't know, is it supposed to be a measurement? I mean, if you do not have a title, if you do not label your x-axis, it's useless. It's artwork. It's not correct at all. It should be a 0. If you don't label things, it doesn't mean anything other than, wow, that looks like it's important to a teacher or somebody, but I don't understand what it is. You always need to run things through your head logically. Can I understand this? If you can't understand it, then why did you put it together? It has to pass your logical filter. And then over here, they did put the unit of measurement millimeters. So pretty good job, but they misspelled it. It's always in lower cases. But you would come to understand that later. But millimeters of what? Millimeters of, I don't know, how big the pot is? How? You just don't know. It would be, they should have said height in millimeters. The title would have been growing 3 plants over 10 days. And then you'd understand, okay, pot A, it's a plant pot, potted, and so on. So you get what I mean, right? I'm really trying to give you examples of what people turned in, sometimes just because it looked pretty. 3, 2, 1. I turn it off and I ask you, what did this chart just tell you? Is this a skyline in Chicago? Right? You think it looks great because, wow, look at all these bars. So the chart's pretty good. They formatted it properly. They got a nice title. Got all the units of measurement there. And then come to build the chart, they're like, boom, yeah. Look at that. Somebody should be able to understand it. Let's see. There's the title right over the legend. So don't turn in something that is overlapping. Drag the legend and put it somewhere where it's not near the title. That's a good title. Density Lab of Liquids and Solids. That's what the name of the lab was. So good title. They labeled the x-axis objects. Good job. That's what it was up there for all these objects right there. Then they get to this and they say grams per milliliter. No, they said milliliters / grams. So they got it backwards because it's grams slash milliliters. And then, is that true? All right, massive object. So this guy right here, water, has a lot of mass. Ooh, that's pretty important. Not. I don't care. It didn't matter what amount of volume you started with. It doesn't matter what you ended with. This was just your working data. See right here? This is just all to get to that number. And so the only important thing to graph would be the end result. You graph all of everything that you've done, and it makes for a colorful pattern, but it's gibberish because the y over here, the y-axis, is not always density. Here you're telling me that it's sometimes milliliters. It's milliliters here, it's grams here, so is that the y-axis, the unit, correct? Now some people caught on to this and they just wrote the word measurement off on the corner, which is really okay, but having too much information in your chart makes it useless. So I'm really trying to drive the point home. This will serve you guys really well. And you know, when I grade your data, I look to make sure that you have a title, an X and Y axis. It's like the first thing I look for. So make sure you don't miss that. And then don't graph everything. Just graph what the lab is getting at. Density. We're trying to get density. We don't care what volume you started with or ended with. All right. I'm kind of putting you on notice, right? Because I'm explaining this several times to the point where I'm boring some people that get this. But I think it's worth getting it right, and then you're going to just build perfect tables and charts for the rest of the year and for the rest of your years in school and in business. All right, let's move ahead to the lab. So please click into our lab here at Canvas. It is called Metric Measurement Lab. Here's a little info on the metric system. So before you get too deep into the lab itself, you do need to know the metric system. So perhaps you got this in junior high, and if not, we're going to go over it. Doesn't take long. The beauty of the metric system is its simplicity. How many inches are in a foot? Okay, you memorize that. How many feet in a yard?
3.
How many yards in a mile? 5,280. Just a random number, right? I could go on with other units of measurement in the kitchen. How many teaspoons in a tablespoon? How many tablespoons in a cup? How many ounces in a cup? How many cups in a quart? How many quarts to a gallon? All of these are not one number. You had to memorize it. It's called the English Standard Unit of Measurement. We inherited it from the English, who emigrated from Europe over to colonize America. So we have their system. The rest of the world doesn't have that system. The rest of the world has the metric system. What is the one number that you have to memorize for the metric system? 10. So easy. So you just have to know the names of the units to go from small to large, And they have done a pretty good job of incorporating it now into our everyday life. So now you can go to the store and buy liters of liquids. Many times in your car, on your speedometer, it also tells you kilometers per hour. So they tried to really do away with the English system, but the best they could do was incorporate the metric system in America, and we sort of used both. But we use the metric system in science. You are responsible for knowing these prefixes. Kilo, like a kilometer, like a kilogram, like a kiloliter. We tend to use kilo for long distances, like with a meter or a liter. Hecto we barely use. That's the next smallest unit to this large one, kilo. Deca, we don't really use that one very often. But we do use deci and centi and milli quite often. So you have to memorize the order, and you can see that there is an acronym here to help you with it. King Henry doesn't usually drink chocolate milk. It's a silly phrase, sentence, that it will help you to remember the order. Now, right here in the middle is what we call the U for the unit, the base unit. The base unit for distances is the word meter. The base unit for measurement, it is liters. And for weight or mass, it's in grams. So we have one of those. And then look, deca and deci both stand for the word 10, like a decade is 10 years. But you have to remember which one is the small unit and which one is the big unit. All the small units end in the letter I. Deci, centi, milli. And deci is very close to deca, and these are the big units. Deca, hecto, and kilo. King Henry doesn't usually drink chocolate milk. You have to remember that. How do you convert from one unit to another? You move the decimal place. You divide or multiply by 10. So right here, if I am at a meter and I want to convert meters into millimeters, you say, how many steps did I go down? 1 step, 2 steps, 3 steps. Move the decimal place 3 times to the right. If I want to say how many meters are there in a kilometer, then you're going to move the decimal place 3 times, 3 ladders to the left. So 1.0, you are, if you're going to go from here to there, you're moving the decimal place. So you're going to do several exercises in your lab write-up for this. There's about 20 different questions for you to do. And it is really quite easy. By moving the decimal place, here we are with a meter. So if I want to go to a millimeter, that was meter, down to decimeter, down to centimeter, down to millimeter. That was a, did I do too many? Meter, deca, centi, no, that was right. So that's moving the decimal place 1, 2, 3 times to the right. So that would be 1, 2, 3. That the answer would be 1,000. There are 1,000 millimeters in a meter. So now you know how to do part of your lab write-up. And I just gave you a little bit of the notes that I just went over. These are the basic units. These are the prefixes you have to memorize. And you have to know these units. It will be on the test. And you need to know, how do I convert from one unit to another? You're going to have it in your lab write-up, and we'll go over it in the next class too. So did you click into the measurement lab? It doesn't take long to get your data for this lab, so I'm going over this in some detail for you. This is a full lab write-up. It's almost all done for you. It's got the title. It's got the question. How many drops of water will equal 1 milliliter? Your hypothesis comes next. The hypothesis is written in an if-then format. Here's how easy it is to write a hypothesis statement. If I use a water dropper, then I will find that it takes 20 drops to equal 1 milliliter. If I use an eyedropper to count drops, then I will find that it takes 100 drops to equal 1 milliliter. So go ahead and write your hypothesis statement right now. It's your guess. You were using the eyedropper in the last class, so you should have some sense for how many drops it takes to get to 1 milliliter. It has to be written in an if-then format, and you write your hypothesis at the beginning of the lab, not after you have run the lab. So basically you're guessing how many drops will it take to go to 1 milliliter using the phrase if-then. If I use an eyedropper, then I will find that it takes 50 drops to equal 1 milliliter. Go ahead and write out your best guess. If I use an eyedropper, then I will find that it takes 20 drops to equal 1 milliliter. Thanks again. She works with Grand Canyon University, and she talked to my forensics class today about the forensics program that they have. Throughout Upper Lunch, starting in a few weeks, they will have multiple colleges visit our campus every day, and they have tables set up for seniors and juniors. And if you're interested in a certain college, you can go talk to them too. It doesn't hurt. We have one of the largest college fairs in America. Sometimes we have like 300 colleges come to our Marilla Athletic Center on college night, and they talk to our students. It's not just for seniors. There are many freshmen and sophomores that go there too. It's not too early to start. So you've got your hypothesis. Here are the materials. 25 milliliter graduated cylinder. Yeah, that one is over there, but I want you to use the smallest one that's over there, and it's only a 10 milliliter. So use the 10 milliliter one. It will be more accurate. And you're filling a beaker with water just so that you have a source for water. You don't have to always go over to the sink for it. Fill the graduated cylinder with 4 milliliters of water. Fill it up to the 4 mark. Remember, that's the bottom of the curve. And then, with a full dropper, start counting. When you get to the 5th milliliter, then you are going to record that number on the data table. Don't let the water drop down the side of the cylinder, because then it sticks there and doesn't become part of the water at the bottom. So if you lower it down, maybe that helps, so that you don't get a lot of the water sticking to the side. Leave the graduated cylinder alone. Now you're at 5. So you recorded how many drops it took to get to 5 milliliters, and do it again to go from 5 to 6. Do it again, 6 to 7. So you're going to do 3 times, you and one other person. Then you're going to check the table next to you and get somebody else's and do it again for someone else. So you're going to have 3 averages. right? So now you're going to, with your data table in numbers, you're going to touch on that and drag it over to here and then hit quick sum and it will, or quick average, and it will average out your three numbers. You can copy the formula here and paste it to the other two groups. It wouldn't even, I mean, it would be a good idea to, why don't you make another fourth row and you could get the average for everyone to do the first one, the second one, third, and then you get the average of the average. So why don't you try that even though it wasn't in there. And then you've got your conclusion questions to answer. Do not use this data table, right? All your data is going to be collected using the Numbers app. And we've done this before where you export your numbers and then you are going to put it in your lab write-up. It's always a good idea to try to get your data right here, but don't just drop over it and make it messy. If it ends up being right here, that's okay. But don't make it come after these questions. So this is the next page. Reorder your numbers table so that it comes right in here. So it's a pretty simple lab, and then there are your metric conversions with the ladder again, and then you answer these as well. So there's a little bit of homework with conversions. Make sure you don't just copy it from someone, that you actually are working on it and understanding it yourself. This will be part of the quiz. Any questions about that? It doesn't ask for you to do a chart. If you want to do a chart, you can. But you're just looking for a nice data table. Yes, I know that you could do the math in your head, but practice creating the data table. And if you wanted to chart anything, chart the averages. You don't have to chart everything. The average is what we're getting at here. So there are trays over here. I don't have them spread around the room, so you and your partner should grab a tray that might be over on this side of the room. You don't need the scale, even though it's on the tray. Just leave it on the tray. And you can now get started.